Hello everyone, this is the demonstration phase of the example code random walker. This is a rather complicated program, so most of the detail are in the book. We're just going to review the features. So this solution 100 autonomous. We define a randomized walk direction and move repeat for the robot to execute. It also avoid obstacle on its own. So we use the alternate algorithm described in the book. So we check the NIR sensor first. If there's no obstacle and it's set up a random walk, set up a number repeat for it, and then it called the function walk execute that make the robot walk. Inside of it, there's some special program to check the NIR sensor again, but we'll get to it. If at this phase here, on the main endless loop, it detects there's a near-infrared detection range, it stops the robot. And then figure whether the robot is frontal, left, or right, and then activate the appropriate avoidance move until it clears the obstacle. And flash the LED 4 times, and then everything goes again, so it will do the random walking again. So this is the main endless loop, so you can see. So if there is no obstacle up front, NR left, NR right are less than the threshold wall, and then go ahead, get a random direction to walk, number repeat, or random motion of repeat to walk, and then call the walk execute itself. Else, that means they found an obstacle. And then set the global parameter obstacle to true and call regular stop. So in here, there's a line command to execute motion index -1. So this is a regular stop. And then beneath this main endless loop, then it is a section of code to check to see if a frontal obstacle. If that case, it go backward. And then, depending on when it's go backward, it pick up whether the obstacle is really on its left more, on right more. It will have a loop while to keep on repeating, turning right, for example, in here, until it clears the obstacle. But somehow, if NIRI is bigger than threshold 3, that means the wall or the obstacle is more on its right side. Therefore, it needs to turn left, and it's a loop while, so it's going to keep on turning left until it gets out of the way. If you notice, it's called walk execute used whether it is no obstacle or whether they're trying to avoid an obstacle. So the walk execute had to be special. It had to be dealing with is whether it's repeating or not. That means there's no obstacle. So then there's no obstacle, the number repeat is executed. So every time it does one of those prescribed randomized move, once it's done it once, it will call, and if the obstacle was false when it first did it, it's going to call check NIR. And check NIR, you can see, you should check the NIR left versus or right versus threshold 1. If any of those true, that means there is an obstacle. And then call emergency stop. Emergency stop means motion 0. Okay, so once done that, you can see that if check NIR comes in and found out that it's an obstacle, the global variable obstacle will be true. So when it gets out, this one will be triggered also. That means it's going to break the loop. So there may be a few of those repeat left, but it will break the loop. So it won't. Will stop very quickly and right away. It won't walk anymore. And so that's it. So I'm going to put the same random walker code, because they're all autonomous, on 2 robots and see how they can play with each other here. Okay, so let me put the camera back on, and let me turn both of them on. Okay, so they start doing that random on their own. Let me put one in the middle here. So let's send this guy get that way. See, touching the air. Oh, they're taking at each other, so they're gonna bump into each other. It's clear. So they're doing random again. Let's see. Oh, they detect each other. Oh. First time I've seen that. Now they're clear. Oh, the one in the back. See the back one? So I have the LED still thing on. Ah, that one picked it up. Turn away. See it.